Time feels like a constant linear path, but the deeper we dive into its mysteries, the stranger it becomes. For instance, did you know that time actually moves slower near massive objects? This phenomenon, called time dilation, means astronauts on the International Space Station age just a bit slower than those of us on Earth, thanks to Einstein's theory of general relativity. Then there's our perception of time. In moments of fear or excitement, our brains process more information, making time seem to stretch. It's not that time itself changes, it's just our brains working in overdrive. And here's a mind bender. There's no universal now. Because of relativity, what's happening right now for you might already be the past or future for someone else in the universe. Time can technically go backward too. The equations of physics allow for it, even if we only observe time moving forward. Speaking of small measurements, the shortest unit of time ever recorded is the zeptosecond, 1/trillionth of a billionth of a second. Scientists use this tiny measure to see how long it takes a photon to pass through a hydrogen molecule. Interestingly, the concept of time zones is a recent invention. Before the late 1800s, towns kept their own local time based on the sun's position. Standardized time was introduced to prevent chaos with train schedules. At the quantum level, some theories suggest that time may not even exist as a fundamental property. It could be an emergent phenomenon that only appears when we observe certain systems. As we age, time seems to speed up. One theory posits that each year becomes a smaller fraction of our lives, making it feel like time is racing by. Time travel into the future is technically possible. High-speed travel and intense gravity can slow time for the traveler. For example, Russian cosmonaut Sergei Krikalev is 0.02 seconds younger than he would have been had he stayed on Earth due to his time spent in orbit. Finally, the arrow of time, this idea that time flows in one direction, is linked to entropy. As disorder increases, time appears to move forward. If entropy were to reverse, we might see time flow backward, although we've never observed that. These facts reveal that time isn't just about ticking clocks or rising suns. It stretches, bends, and even vanishes under extreme conditions. The more we learn about time, the more complex and fascinating it becomes.